Hello everyone, welcome to EEEE lecture number 3. Today we are going to continue the topic on resistive network simplification. So let's start with numerical number 1 for today. So it says that find the equivalent resistance, find the equivalent resistance between A and B. Alright, so let us draw the circuit first. So this is my resistor, these are my three resistors. This is my point A and B. Well, they have given additional information as follows. So here there is one line and here there is another one. Alright, let me mark this as like this. Alright, all the value of resistors are 10 ohm and we need to find equivalent resistance between point A and B. Alright, so last time we have studied about series and parallel circuit. We know when two resistors are in series, they are connected as follows. So these two resistors are in series. So let's say R1 and R2. So what will be the equivalent resistance? Let's say this is A and B. So equivalent resistance RAB will be R1 plus R2. This is in series. In parallel, the resistance will be connected as follows. Both the ends will be tied together. So if this is point A and B, your RAB will be, this is R1 and this is R2, it will be R1 parallel to R2. Got it? Now, in this case, it's slightly tricky. So, what we do is let us designate certain nodes. So, let us call this node as C and this point as D. All right. So, this is A, B, C, D. And let me redraw the circuit as follows. So, if this is A, all right, this is B. Let me mark D over here, and let me mark B to C over here. All right. Now let's connect the other resistors. Alright. Let us first connect this resistor 10 ohm A to C. So this resistance is connected between A to C. So from here I'll connect it and connect it like this. Okay, A to C. B and C are one and the same point and A and D are one and the same point. Now next resistor, let me take another color and this 10 ohm. So between C and D. So between C and D we'll connect one resistor of 10 ohm. Alright, then let us connect the last one between D and B, so from here we have connected a resistor. So now if you see carefully, all the three value of resistors are connected in parallel. So what is equivalent resistance RAB looking from here? So RAB will be this 10 kilo ohm parallel to 10 kilo ohm parallel to 10 ohm. Okay. So we will find by using the other formula, that is 1 upon RAB is 1 upon 10 plus 1 upon 10 plus 1 upon 10. So with this, if you find the value of RAB, that value will be 10 by 3 and its value will be 3.33 ohms. Alright. So this is the value of resistance, equivalent resistance between point A and B. So equivalent resistance between point A and B, we can write it as RAB. Got it? So next time, whenever we find the equivalent resistance between any 2 points, we can write it as RAB, or between those 2 points, whatever name is defined there. Alright. Now you can check it out easily in LTspice, this thing. So we'll recreate the circuit in LTspice and let us see whether we get the same answer or no. So let me go to LTspice. Okay, and I'll adjust to the screen. So LTspice is a tool, software tool, wherein we can verify any linear circuit easily, consisting of resistor, voltage source, and current source. Alright, so let us create a new schematic, and now we take the resistors. We have to rotate it, so press Ctrl R. I have kept it over here, another one over here, and third one over here. Okay, I'll recreate the original circuit and I call it as RAB. Alright, and then I'll connect the three together. Let me adjust to the screen. Okay, so I'll connect them, three of them together like this, and then we have internal wires connected. So this A is going to this D. Alright, and over here, from here, it goes over here. So the circuit is exactly as the way it is shown over here. Alright, now we'll mark the resistance as 10, 10, and 10. Alright, and we'll also mark the nodes. So this is my node A. I'll right click on the wire and click on label net, and I call it A. This is A, this is C, D, and this is B. So let me call this as B, let me call this as D, and this as C. Actually, C and B are the same points, so no need to call them as follows. And A and D are the same point actually. Alright. Now, in order to find resistance in LTspice, we will find a resistance by adding a voltage source, and then whatever the value of the voltage source is, we'll divide by the current flowing through that voltage source. So let us connect a voltage source. Okay. So let's go to components and type there voltage. So here is my voltage source. So I'll connect the point A to the positive. I don't know the value of the, resistance doesn't have any polarity. So I'll take the wire and connect it. So from B over here to the negative end, and from A to the positive end. And of course, I need to connect the ground also, because without that LTspice will not work. So I'll connect the ground to the negative supply over here. Alright? Okay. So my circuit is ready. Now always remember, I'll give this value as, let's say, 10 volt. Alright. Now always remember, in LTspice, current flowing into the current source from positive to negative is considered as positive. Current flowing out of the voltage source is considered as negative. So don't panic if you get a negative current. Okay, I'll simulate this. So I have to click on run and click on DC operating point and then click on OK. Okay, so here it is. I am getting the current. So here, as I have said, the current is coming out to be current flowing through V1 is -3. So I told you the current flowing out of the current source, out of the voltage source is considered as negative. So that's why over here the current is showing negative value. So don't worry about it. We have to consider positive only. So what is the voltage over here? Voltage is 10 volt. 10 volt divided by this current. So 10 by 3. And that is what we got. 10 by 3. So let me write over here. Okay. This device current will be positive only, as I have already told you the reason why. So let me go to draft, comment. So this is my value of current, right? Now I'll press Ctrl M to go to the new line. Then I'll write RAB equal to R equal to V1 divided by voltage divided by current, right? Divided by I of V1. So that will be 10 divided by 3 ohms. So that is the current. Got it? So this way we can find equivalent resistance of any circuit. I hope you're following. We got it as 10 by 3, and here also we got it as 10 by 3. Don't worry about the sign of this current, because it's the adjustment done in LTspice. Alright. Now let's go to the next numerical. So let me maximize this. Got it? So this way we can ask this numerical in exam for, let's say, 5 marks or so. Now let's go to numerical number 2. So let us write it down. Find numerical number 2. So instead of writing find the equivalent resistance between point A and B, I'll write just find RAB. Okay, just to save some time. Okay, numerical number 2. Now let me draw the circuit. So circuit is as follows. So we have this resistor. All this bunch of resistors are connected in a square like this, and here. So these are point A and B. These resistance are 8 ohm, 6 ohm, 10 ohm, and 12 ohm. Also, two more connections have been done. This diagonal is connected, and this diagonal is connected. Okay, let me draw this properly. All right. So this is the given numerical. We need to find equivalent resistance between point A and B. So let's do that. Now, how to do that is, first of all, we'll define additional nodes. So this is actually, this node is same. This is A, this is B. Let me call this as C and this as D. And let us rebuild the circuit, one by one. All right. So let's do that. I'll do it over here only on the side. So first of all, I'll draw A, and then on the other side, I'll draw B. So A is directly connected to D, so I'll connect on the other end D, and B is directly connected to C. So on the other end, I'll connect C. All right. Now let us trace one by one. So let me take different colors. So this 8 ohm, I'll represent it's connected between A and B. So this 8 ohm is connected between A and B. Got it. Now next, I'll connect this 6 ohm between A and C. So between A and C. So this is A and this is C. So this is 6 ohm. Then next I'll connect 10 ohm resistance connected between C and D. So connected between C and D is 10 ohm. And then we have a 12 ohm resistance. This is 12 ohm connected between B and D. So this is B and this is D. So this is 12 ohm resistance. Alright. So what do you see? What do you see? All the resistance are connected in parallel. Alright. So what will be RAB? So 1 upon RAB will be 1 upon 8 plus 1 upon 6 plus 1 upon 12 plus 1 upon 10. So basically we can say RAB is 8 ohm parallel to 6 ohm parallel to 12 ohm, and that is parallel to 10 ohm. Alright. So if you solve this in the calculator, you'll get the answer of RAB as 2.105 ohms. Alright. So please cross check this answer. This is 1 upon RAB. So RAB will be, whatever answer you got, 1 upon that. So this is how you can simply find, equivalent resistance between points, between terminals A and B. Alright. Now let us check it out quickly this in LTspice. So what I will do is I'll keep this circuit over here and I'll create a new schematic, and I quickly take some resistors. So these are my resistors. I'll rotate it, and now I'll connect them together with a wire quickly. Alright. And they have to be interconnected from internally also. So from here I'll make the connection. From outside also you can connect it, but here I guess, okay. So from here it's connected to this point, okay, and from here it's connected to this point. See this cross connection, this connection is not made because whenever a connection is made, this square color, black thing comes, okay. So this connection is not made, this is cross coupled, and these are my points A and B. This is A and this is B. So we need to find equivalent resistance between A and B. So let us do that. This is A and this will be B. Alright. Now, how to find the value of equivalent resistance? First of all, let me write the values. This is 6 ohm and this will be 10. This will be 8 ohms and this R4 will be 12 ohms. Okay, as it is. Then we need to connect a voltage source, let's say of 10 volt between point A and B, and give that value as 10 volt. So 10 volt divided by whatever the value of this current flowing through this V1, that will be my equivalent resistance. Voltage divided by current will be my equivalent resistance. I have to need to add the ground also, like this. Now let me simulate the circuit. DC operating point, click on OK. Okay, so here we are getting again the current negative. Don't worry about it, because the current coming out of the voltage source is considered as negative by LTspice. So its value is 10 divided by 4.75. So you can check it out. Let me see if I have a calculator nearby and check this answer out. Yeah, so I'll divide 10 divided by 4.75. That comes out to be 2.105. Exact answer I'm getting 2.105. You can check it out. Okay, so let me copy this and I'll add it over here. I'll right click, draft, comment. So this is my current. So basically my RAB will be V1 divided by I of V1, which is nothing but 10 divided by 4.75, which is nothing but 2.105 ohms. That's the answer I'm getting. Okay, don't worry about the sign of this negative sign of this current. That's I've already informed you. So it's the LTspice thing. Okay, so this answer and this answer is again matching. In fact, any circuit, equivalent circuit or linear DC circuit, any circuit, we can check it out like this in LTspice. Okay, okay. So now let's move on to a next concept, which is an important one. This is delta to star transformation. So let's begin. Let me start that in a new page. Okay, so we'll write over here delta to star transformation. All right. So sometimes it happens that any resistive network, it's not you cannot simplify it simply, right? Just by parallel or a series combination. So in those cases, we require delta to star and star to delta transformation. So let us begin with delta to star. So first we have a delta network. So let us draw a delta network. So let me go back to my black pen. So this is my delta network. So just like a triangle, like a delta. Okay, let me call this points as this is 3, this is 1, and this is 2. And let me call these resistors as RA, RB, RC. No need to remember this notation, just remember the concept. So this is my delta network, delta resistive network. Okay, and I need to convert it into star. So star looks like this. So this is my star connection. This is R1, R2, R3. So these are my points 1, 2, and 3. So this is my star network. Now either I can convert delta to star, okay, either I can go from delta to star or star to delta. Alright. So first we'll go from delta to star. Alright. So for that, let me redraw the delta network a little bigger. So this is my, I'm redrawing the delta network. You'll understand why I'm drawing a little bigger. Okay. So this point I'll call it as 1, 2, and 3. I named this resistor as RA, this is RB, and this is RC. Alright. Now if you want to create a star out of it, just create it inside. Okay. With a pencil you can do that. So this is how I'll create a star, right? So this is R1, this is R2, and this is R3. So what I'm doing, I'm going from delta to star. Alright, now I need to know how to calculate the value of R1, R2 and R3. So listen very carefully. We can write the value of R1 as follows. So R1 will be If you see what is there in the same leg of R1, in the same leg of R1 we have RC and RB. Got it? RC and RB. So it will be RB, RC divided by, now each of them we can multiply RC, RB plus RB, RA plus RA, RC. Or we can, you can do this for R2, R3, right? So R1 will be adjacent resistance, that is RC and RB divided by total, that is RA plus RB plus RC. Got it? Now similarly, how do we write R2? So R2 will be, what are the adjacent resistances? RC and RA. So it will be RA RC divided by total resistance RA plus RB plus RC. Similarly, what will be R3? R3 will be, these two resistances are adjacent to it. So it will be RA RB divided by total resistance. So this internal network, blue one, is my equivalent star network. Okay. So these are the formulas. So please, note it down. So we are converting from delta to star, and these are the formulas. The adjacent resistance divided by the total resistance. So the whatever, don't go by the notations over here. RA, RB, RC can be written anywhere, and R1, R2, R3 can be written anywhere. Just remember adjacent upon total. Okay, adjacent multiplication divided by total addition resistance value. Got it? So this is the first one, delta to star. Then we'll go to now next one, that is star to delta transformation. All right. So for this, first I will draw a star network, bigger one. Okay. So this is my star connection 1, 2, and 3. Let me call this as R1, R2, and R3. Now I need to convert this into delta. So what is delta? Connection between 1 and 2, like this. Then 1 and 3, like this. And here there is another resistor. So I need to go from inner to outer now. So this is RC, this is RB, and this is RA. Got it? So I need to now know the values of how to write the values for RA, RB, and RC. Okay, we are going from star to delta. So the RA will be, so here it will be like this. Multiplication of resistances, all the resistance, internal resistance. So R1, R2, R2, R3, R1, R3 divided by, now opposite to RA, what resistance do you see? R1. Okay. So denominator, you will get R1. And numerator will be same for all. R1, R2 plus R2, R3 plus R1, R3 divided by R1. Similarly, RB, numerator will be same. R1, R2 plus R2 R3 plus R1 R3 divided by, now opposite RB, what resistance do you see? Internal R2. So this will be R2. Similarly, RC will be, opposite resistance will be R3. So denominator you will get R3. Numerator you have R1 R2 plus R2 R3 plus R1 R3. Got it? So in this manner, we'll convert a star connection into a delta. So this is called as star to delta transformation. Now this will be extremely helpful to simplify the resistive networks. Got it? So please note it down in your books. I hope you have noted down still. Okay. All right. Now we'll go for the actual numerical. Okay. So let me take a numerical in new page. I hope you have understood star to delta and delta to star transformation. Now we'll solve numerical number 3 for today. Okay, so we'll see two more numericals and then we'll call it for this lecture. So let us find equivalent resistance between A and B. So we will write find RAB. Got it? Now let me draw the network. So this is my network. Okay, let me redraw it properly. Okay, all right. So this is my here also there is a resistance. So please draw along with me. Then I have a resistor over here. Then I have a resistor over here. And lastly, I have a resistor over here. So this is terminals A and B. So let me write these values of resistors. So this is 4.5 ohm. This is 7.5 ohm. This is 3 ohm. This will be 4 ohm. 3. This is 3. This is again 4.5 and 7.5. So if you notice carefully, this section over here and this section over here are exactly symmetric. Okay, so what will you convert, delta to star or star to delta? Yeah, got it. So here if you see carefully, this connection 4.5, 3 ohm and 7.5 makes a delta connection. So I'll convert this into star. So let me maximize this a little further and let me draw this as a star network now. So this is my star network. I need to find R1, R2, R3. So here also it will be R1, R2, R3 is one and the same because the values will be similar. So I need not find it again and again. So this one will be R1, this one will be R2, and this one will be R3. Got it? It's exactly symmetric, right? So no need to write R4, R5, and R6. It's one and the same because it's symmetric. Okay. So now let us find the value of R1, R2, and R3. Got it? So let's write solution. So here we have used what? We have used delta to star connection. Okay. So for this, what is the value of R1? What did we say? Opposite, adjacent value of resistance. So R1, what is connected? 4.5 into 3 divided by total resistance. So first of all, let us find the total resistance. So it's 4.5 ohm plus 7.5, that will be 12 plus 3. So total resistance is 15 ohms. So R1 will be 4.5 into 3 divided by 15. Got it? So that will come out to be zero point 0.9 ohms. R2 will be, R2 is over here. So these adjacent values are 4.5 and 7.5. So 4.5 into 7.5 divided by 15 total resistance. So this value will come out to be 2.25 ohm. Got it? So, and please calculate this in calculator. So R3 will be, adjacent value of resistance are 7.5 and 3. So 7.5 into 3 divided by 15. This will come out to be 1.5 ohm. Got it? Okay. Now we have to redraw the circuit. But here students make a mistake. They don't disconnect this values, that is 4.5, 7.5 and 3 ohm. So these are already converted into a star network. So I'll draw a yellow line. Only those network we need to redraw it now again. Okay. Along with this. So no need to include this 4.5, 7.5, 3 ohm again. We'll redraw this network with the required values. So let's do that over here. Let's go down and let's recreate this circuit once again. Okay. So I'll first have over here, let me take it properly. Okay. So this is one part, this is second, and here again we have a branch. So this is B, this is A. Now let me make it a little small so that I can compare. This is R2. So R2 is how much? 2.25. So this is 2.25. This is R3. So R3 is 1.5. Similarly, here also we have 1.5 and 2.25. Okay. Here this is R1. Yeah, as you can see, this is R1. R1 is zero point 0.9 ohms. This is zero point 0.9 ohms, and this value is 3 ohms. And above this number is this resistance value is 4 ohms. So this is 4 ohms. So this is how you create, from delta to star. All right. Now need to work on this circuit and then simplify it further to calculate RAB. Now if you see carefully, these three resistance are in, okay, let me just, okay, yeah. These three resistance 0.94 and zero point 0.9 again are in series. Similarly, the other three over here, 1.5, 3 ohm and 1.5 ohm are in series. Okay, and the value together will be in parallel. So what does that mean? That means we can write zero point 0.9 plus 4 plus zero point 0.9 ohms parallel to 1.5 ohms plus 3 ohms plus 1.5. That is saying this is 5.8 parallel to this value will be 6 ohms. Okay, so the equivalent resistance you can find out. So this value is 5.8 and this value is 6. If you find it out, this will be 2.95. Got it? 2.95 ohms. 5.8 parallel to 6 ohms will be 2.95 ohms. So you got it? This yellow color series of resistance will be parallel with this blue color series of resistance. Okay, so 5.8 parallel to 6 will be 2.95. Now I'll draw the circuit again. So between A, here we have 2.25 ohms. So this is terminal number A, and we have the series, parallel resistance combination, which is 2.95 ohms. And here we have again 2.25 ohms. So this is B. So for now, it's very straightforward. All the three resistance are connected in series. So RAB will be 2.25 plus 2.95 plus 2.25 ohms, and that comes out to be 7.45 ohms. Okay, so please cross check this answer, please. I'll give you all some time, some seconds to note it down. Okay, so I'll repeat what we did first. So first we converted this delta network into star. We found out the internal value of resistance R1, R2 and R3, and then we recreated the network, okay, and found out that these three are in series and these three are in series, so together they are in parallel. So we found out the equivalent value, and then we found out that the equivalent resistance is the combination of three series resistance. So we got the value as 7.45 ohms. All right, so let's go to the last numerical for the day. Okay, so let me write over here numerical number 4. So again, numerical number 4 will be to find R, A, B. Okay, so now let me draw the circuit first. Let me go down again. Yeah, let me draw the circuit. So here will be, I have, so this is my network, and internally I have this as well. Okay, and here is B and here is A. Okay, slightly tedious. We have a delta and inside we have a star, and we need to find the value between equivalent resistance between A and B. This is 9 ohms, this is 4 ohms, 6, this is 1.5, this is 3 ohms, and this is 1 ohm. And now we'll have to find out the equivalent resistance between point A and B. Okay. So always solve the inner loop first. So inner we have a star, right? So solve it to delta. Okay. So what I will do, I'll use a red color. So inner star we will convert into delta. So what I will do, this is the resistance. So I'll convert it into delta. So this is my delta now. Got it? Inner star I'll convert into delta. Sorry. So this is R1, R2, and R3. Now when we convert, we will be converting star to delta, inner star to delta. Okay. So what is the value of R1? As I told you, R1 will be, earlier I have told you, what is opposite to R1? 3 ohms. So denominator will be 3 ohms. Numerator will be the value 6 into 4 plus 6 into 3 plus 3 into 4. Okay. So that will be 6 into, 4 into 6 plus 4 into 3 plus 6 into 3. That comes out to be, if you solve it out, this is 18 ohms. Okay. Similarly, R2. Denominator will be fixed. R2, what is the opposite resistance? 4 ohm. So divided by 4. Numerator will be same. 4 into 6 plus 4 into 3 plus 6 into 3. And this comes out to be 13.5 ohms. Similarly, we will find R3. R3 opposite resistance is 6 ohms. So divided by 6. Numerator is same for all three, and R3 comes out to be 9 ohm. Alright, so we got the value of delta network now, and now we need to connect the circuit. Okay, we need to connect the circuit without these resistances. So what are the resistances we'll disconnect? 4 ohm, 6 ohm, and 3 ohm. Okay, so we'll disconnect this and we draw the network again. Alright, so let's do that. So here if you see, 9 ohm will be parallel to 4 ohm. Sorry, not 4 ohm. This is not 4, this is R1. So that is 18 ohm. Then over here, 1.5 will be parallel to, will be over here. This will be 13.5. And here will be R3 parallel to 1 ohm. Okay, so let me draw that over here again. So don't worry, we will draw the network again. So let me draw it. So after converting star to delta, we have got this network. This is A, this is B, and the inner network I am also drawing again. So we got this. Let me draw this again. Okay. Uh, all right. So this value over here is 9 ohm, and this was R1, so this is 18 ohm. This value will be internally 13.5, what we got, and this was 1.5. Here the value was 9 ohm, and we got it here as 1 ohm. So if you see carefully, 9 ohm and 18 ohm are in parallel. Similarly, 13.5 ohm and 1.5 ohm are in parallel. And in the other case, this 9 ohm and this 1 ohm are in parallel. Okay. So these three resistance are in, we will find out one by one. So let us first calculate 9 ohm parallel to 18 ohm. So this comes out to be 6 ohm. If you work out in the calculator, this will come out to be 6 ohms. Then we have 9 ohm parallel to 1 ohm. This comes out to be zero point 0.9 ohms. And then last one, we got 13.5 ohms parallel to 1.5 ohm. If you notice carefully, the equivalent resistance, the parallel resistance, what we get over here will be value will be lesser than the lower value of resistance. So here it is lesser than 9 ohms, here it is lesser than 1 ohms, and here it will be lesser than 1.5 ohms. So that will come out to be 1.35 ohms. Okay, so we will draw the network again now. All right, so we will draw this. So and we write the equivalent value of resistance over here. So these are points A and B. So this value will be around 6 ohm. This is 1.35 and this will be zero point 0.9. Alright. So now what do you see over here? Which resistance are in series or parallel? Yes, you are thinking correct. 1.35 ohms is in series with zero point 0.9 ohms. Okay, they are in series. So let me draw the network again. So here we'll have 6 ohm and then we'll add these two resistance. It will be 1.35 uh, plus zero point 0.9. That will come out to be 2.25. You can check it out. It will be 2.25 and here I have A and B. Okay. Now these two resistance are in parallel simply. So RAB will be 6 ohm parallel to 2.25 ohm. So the equivalent value will be lesser than 2.25 ohm and that value comes out to be, if you work it out in a calculator, 1.64 ohms. Okay. So the equivalent resistance between terminals A and B will be 1.64 ohms. Alright. Now let us check it out in LTspice and check the value of resistors if the value is coming out to be correct. So let us try this out in LTspice. So let me create a new schematic. So here I'll add the value of, I'll add the resistors. First I'll add the internal resistors, then I'll add the external resistors. So let me add over here, this is one resistor, one over here, one over here, and one over here. So these are my internal 6 ohms. Let me give the value also to it. This is 4 ohms and this will be 3 ohm. Okay, and now I have to connect the external resistors. So I'll slightly minimize it and I'll add the resistors over here now. This is the ones, the second one, and the third one will be over here. Now I have to connect the network together. Okay, so here it is. Let me connect them together quickly. First I'll connect the internal resistance. So these are my internal resistance. This is my inner network R1. This is 6 ohm, 4 ohm, and 3 ohm. Okay, got it? They are not connected like this. They are like unequal. Okay. Now here let me also give the value over here. This is 1.5 ohm. This value will be 1 ohm, and this value will be 9 ohm. Okay. Now I'll make the connection. So 9 ohm and 6 ohm are connected. So I'll connect it like this. I cannot bend, I can have a right angle line over here. That's why wire over here. That's why I'm connecting it like this. This 1.5 is connected to 6 ohm. Now this 1.5 is connected to 3 ohm and 1 ohm. Okay. So I'll connect it to 1 ohm as well. And I also connected to 3 ohm like this. Got it. Now similarly, I'll connect this 9 ohm is connected to 4 ohm and 1 ohm. So this 9 ohm is connected to 4 ohm and the same is connected to 1 ohm. Okay, so my circuit connections are completed. Now I'll mark the terminals A and B. So this is terminal A, let me mark it, and this is B. Okay, I'll right click on the wire, label it as A and this as B. Let me label it properly on the wire. So this is A and this will be B. Now in order to calculate the equivalent resistance, I'll connect a voltage source of 10 volt value. So whatever the current flowing will be over here through the voltage source, the value of the voltage source divided by the current flowing to the voltage source will be the resistance. So here I'll right click, I'll give 10 volt over here. Also I need to connect the ground, so I'll connect the ground below. So yeah, here it is. Remember, in LTspice, the current flowing out of the voltage source, that is from negative to positive, will be considered as negative. Current flowing into the voltage source is considered as positive. I hope it is clear. So even if you get a negative current, don't worry, it's because of LTspice. Right click I mean, I'll go to simulate, click on the run, then go to DC operating point, then click on OK. All right, I am getting the value. See, V1 is around 10, and the current flowing through it is, 6.11. So 10 divided by 6.11, that I am getting close to around, how much was the answer? 1.64, and I got the answer as 1.636. So it's almost same. Got it? So yeah, I'll note it down. This current over here, six. I told you, do not worry about the negative sign. Okay. The voltage divided by the current flowing through this voltage. So here I'll write it down. I'll go to draft, go to comment, and I'll add this current. So I'll write RAB will be voltage V1 divided by current flowing through V1, which is 10 divided by 6.1111, and that comes out to be, I got in the calculator as 1.6363 ohms. Okay, that depends upon whether in the calculations we take up till 4 digits or 3 digits. So I've taken up till 2 digits, so that's why we got it as 1.64, and here we got it more accurate value in LTspice as 1.6363 ohms. So in this way, we can check any circuit, any linear circuit, any resistive circuit, uh, any linear circuit consisting of resistor, voltage source, and current source. Easily check the answer in LTspice. Now I'll give you the last numerical for homework, so you can solve it on your own and test the concepts. So kindly note down the numerical. So this is numerical number 5, and this is for your home assignment. Okay, and this is for home assignment. So note down the circuit. So this is fine. Okay, let me use black color. Find equivalent resistance between terminals A and B. That means find RAB. And this is my circuit. All right. This is, okay. Yeah, exactly, precisely. This is my network. These are points A and B, and all the value of resistance are 10 ohm. So work it out at home and calculate the equivalent resistance between point R, A, B. You can use the concept which we have done, before in this lecture. All right. So that's the end of lecture. That's all for today. Next time we'll start with, some other topic. So also let me give you, before that, let me give you the value of RAB. So equivalent resistance comes out to be 10 ohm. So please calculate and verify this answer. If you have any difficulties, you can reach out to me. So that's all for today's lecture. Thank you all for joining.